Alright, we're going to try to find the relative extrema for this function 2x cubed minus 9x squared minus 60x plus 4. So we know we need to start by looking for the critical values of the function. We know where the critical values occur. I'll use the abbreviation CV, where the derivative is equals 0 or the derivative doesn't exist. But for this function, being a polynomial, that doesn't happen. So let's start by finding the derivative of our function. 6x squared minus 18x minus 60. Alright, we'll set that equal to 0. That'd probably be more easily done if it didn't have the common factor of 6 in there. So we'll pull that out. So 6 is obviously not 0, so hopefully the quadratic is. And if it's nice, it'll factor pretty easily. X and X, probably a 2 and a 5. But I'll need a plus and a minus, probably a plus 2 and a minus 5. Leaves us with a sum of -3 and a product of -10. So I found them. I've got the critical values at x equals -2 and x equals 5. Problem is, I don't know which of these are a max and which are a min, if any. So here you could use one of two tests. You could use the first derivative test, or what I would prefer is the second derivative test, which is a little quicker. So for the second derivative test, we'll find the second derivative of f, which would be 12x minus 18, and then we'll just directly find the second derivative at these two places. Really, I'm just concerned with the sign. -24 minus 18. Honestly, I'm just concerned that it's negative. Sure, it's -40, but I'm just concerned that it's negative. When I plug in 5, I get 60 minus 18, which is 42, which clearly is positive. Now, why do I only care about whether they're positive or a negative? Well, in short, just to sketch out to the side, if the second derivative is negative, that means the interval that your critical value is in, -2 is a critical value, must have been concave down. And if your critical value is in an interval that's concave down, well, man, he must have been a maximum. So we see we have a relative max at x equals -2. And when we plug in 5 in the second derivative, we get a positive, which means it's concave up. And if your critical value, 5 is a critical value, is in an interval that's concave up, it must be the minimum. So we've got a relative min at